suppose you want to export some model from your designing software, like this is Pro Engineer, and you have some model, some complicated model made on this, and you want to export this model to Abaqus or any other analysis software. So this is important. So you have to search a common format first. So in case of Pro Engineer, you want to export, go to File, save a copy, or you can export this in some other softwares, and search for the type. You will get a lot of types here, a long sequence you can see. So in this you can see part, IGS, set. So I think IGS is common between your Pro Engineer and Abaqus. So we are exporting this IGS name wheel in desktop. We have just exported, this one is exported on here, so I'm cancelling it, then go to the Abaqus and you have to import. So just go to the file, go to the import, go to the part, click, this is the wheel, change it into IGS, this is common, IGS star or IGES. Just click on wheel and click on OK, and this is the imported one. So you have imported this wheel. Similar to this model, you can import other things like tools. So you have one or two websites. So I have this one website in which a lot of milling tools are shown. So you can download any milling tool. So if you will click on 3D, or so you can see rotating tools. This is a very good website and you can trust on it. So you can zoom out, you can zoom out. So which one you want to download?
That six one.
But this is not a straight milling tool. Wait. 6.1. This one?
No, left one.
This?
Yeah, that one. It's not working.
It's not working. But we have to cut this, right?
Yeah.
Okay, we can see this. But it is a parted. Two parts are there. So we can see this one is a big milling tool. And in 3D, we need one flute only, right? This I think okay. We will cut all the portion. We will keep only this portion. Okay. So cross it and download all. It will download in one file, only one file. So this is downloaded. Right click, so in the folder, and just open it, close, and extract. Okay, milling tool. Rendering. This is the milling tool. This is just image. What is the format of this? Do you know the format? No. Okay. Just copy it. Put it on my computer, D drive. Make a folder. DMK. This is your name. Okay. Just paste it and open Pro Engineer. Go to the file. Set working directory. Go to the D drive. Where's the DMK? DMK is no working file, right? And file, open DMK. So change the type part, or you can put here star.star. I think it will show all the files if it is. This is .lsldprt, right? SLDPRT. You have this. think this is not available. SLDPRT in Pro Engineer. Do you know about SLDPRT? Do you know about SLDPRT?
Yeah, so it is a SolidWorks file.
SolidWorks?
Yeah.
So it must be there.
Can I open that SolidWorks file?
It can open SolidWorks file.
Just open that. What about?
So where is this?
Yeah.
Not really. Okay, try to open.
No there.
No.
You can't read this. This is right?
DDMK. You can check from here. DDMK bearing. Open directly. Just drag it.
No there. What about just open abaqus Pro?
You want to trim that tool, right? So trimming is not possible in abaqus. Possible but very difficult. But in abaqus, can you import SLDPRT?
Right.
DMK SLDPRT, because it has very less option.
Okay.
Only few options are there.
Okay. Just finding finding the milling tool for the wire. What's that? The PT?
Other file.
For engineer.
In Pro Engineer, a lot of options. GS, CT, VD, SLD.
Why don't you find other one?
Other one?
Yeah, other tool.
Okay. We can search.
You use that milling tool file from this website?
Yes.
Yeah. That one.
Milling.
Why don't you use the given one?
Which one?
What you used in your simulation?
I forget where is that. What if you search? Can search where is that? This may be in file. Set working directory. Turning. I don't know where is the file.
Do you remember the file name?
No. I do not remember. Actually, the file was taken from this website. Now I cannot see that
Search other one.
drilling tool. It was a milling tool. It is not available here now.
That file is also
It's still SLD. Yeah, I see. Change the keyword to machining tool.
All files is not visible here. Why?
Because they can't read the SolidWorks file.
Maybe e-drawing
Here.
file. Right.
Oh, you can change from here.
Maybe you can save it as a
Save as.
Let's say
no
this.
there.
Yes.
Oh, this is the machining program.
EPRT.
EPRT. Where?
So first one.
What's it?
This one.
This one.
Where is
D drive.
it?
D drive. DMK.
Yeah.
Which is EPRT.
EPRT.
Right. Search here. EPRT is there. Change EPRT from here.
Not there. Is your computer only install the program?
Only Pro use.
only? 인원아 뒤에 컴퓨터 보면 소리가 좀 나요.
이거요?
금방 바꿨어. 아마 오토 So your the data that one
This is in
그 머신인 시뮬레이션 데이터. In that folder, the folder have you use them using the milling modeling
yes.
in their folder. So
I used milling modeling, but where is that? I did not know. I forget where is the part. This is 4 months back. I did all this analysis. But PRT, I can start PRT here. PRT. Okay, so all the PRTs.
Should I sign up for a download?
Yes, this milling 3 milling
Download. Does it work?
No. Here's the milling tool, I don't know.
Why don't you use the other one then? Please turn the grabcad side.
Identified. At the end. No. This is end mill. Second copy. And this is DMK. You can try to open it.
You just press the tab key.
there you grab. Okay.
Down.
No.
Uni graphics.
This one.
Ease.
I don't know what will come.
Dildo.
Something will come. So
소리.
Correct.
틱톡.
Waiting.
디투.
Experiment.
I have one question.
What is the question?
When you find the lots of parts, can you cut the end of parts like this?
Yes,
For example?
We can cut.
Oh, really?
No, but not here. Not here.
Oh, it's still fine.
Yes, this is steel file. And now look, 20 mm tool. Original copy. This is original STL file.
Still.
They're still thinking, what is that?
I think that the file is so long, like so big files.
This original is not 3D viewer is different thing. This is different. So this is file. What is the size? Oh, this is 1.3 MB. This might be the original 20mm dual file.
Just close that and then just open.
Close?
Open that thing.
The program.
Go.
Just go.
You can only website in a Pro program.
This grabcad. I know only one this, but you can search more than this. It is again not responding. So STL 3D STL is common in Pro Engineer. I think these two I have downloaded.
Roger? Oh, and
This is ball and mill. This.
that's The third one. Okay.
Which one? This?
Yeah.
This is STL.
Yeah.
This is original one.
The name of file is original.
Yes. Then D drive.
Oh, change the O file.
STL. This is not required.
This has previous one.
We have original one. Original.stl.
I think you need.
This is shown, but this is not shown.
Why don't you change the name?
Here?
Yeah.
Billing. Okay. So you need only this one.
Yeah.
Right. So we will cut all the portion which is not required. So just go to the insert.
You now cut that only that part?
Yes.
One.
One plot. And this is the plane. To cut it. It has no planes. Okay. I think I have to save it in some other format, then it will work. It's very simple. Copy in DMK in part format.
포화통이 엄청나게 문제네요. 다 한 번에 포함할 수 있는 프로그램 만드는 게 빨리.
있어? 뭐야? 오토캐드에서 나온 거 있잖아. 세이프 지역에서는 그거 다 열려? 걔는 천하무적이야 진짜.
PRT. So define.
What's the problem?
Cannot select this plane to cut it.
offset of the plane.
But I cannot select any point. Okay. Simple, difficult. Is it difficult or simple? I think it's difficult. One software cannot understand others' language.
Alright.
Actually, if you want, you can generate your own tool. Can you generate your own tool in CATIA?
I haven't one. I have one, but I will try to change the file type from CATIA.
So if you can generate your own tool, then this is very good. Files at working directory. Browse dmk. Okay. Open database. This is abaqus. Files. Set working directory. dmk. Okay. Meaning part 1. Insert, extrude. It has no plane. I think it is better to generate your own tool.
Okay. Can you make it?
Okay, I'm trying to make one tool. Okay, so for making a tool, first you make some cylinder. Okay, so what is the diameter you need?
30.
30.
30.
30 millimeter. Okay. And the length?
70.
70. You need some flank also.
Oh, okay.
Okay. Now you have to cut it. Now insert helical sweep. Nitrogen. Not this. Insert helical sweep. Cut. Okay. Done. Set up a plane. Plane. This is okay. Sweep cut or helical cut? Helical sweep cut. 100% through axis. Okay, so one is line from here to here, and one should be the axis. Enter some pitch.
Or if I will make my new own design.
You can make a tool, right?
Yeah. I will make it. Yeah.
Okay, so make a tool.
Can I sweep the tea?
Hmm?
Do you want to sweep the tea?
Tea?
Tea. Coffee.
No, it's okay. I think we can stop it for some time. Pause.
Push. Yeah.
Resume. Okay, so go to the
Oh,
file.
Did it start?
It is started, I think.
Oh yeah.
It is running.
Yeah.
Just file.
Yeah.
It is very simple. Just
Yeah.
import with import. This is import part. And go to your
USB. My USB.
just give it the name of your J.
Is it right?
IGES. I have to search G. This is G.
Yeah, G.
This is not J. This is G. A, B, C, D. Where's the G?
Hmm?
File. Import part. No, D is not there. Okay, no problem. We can copy it.
Yeah.
Which one is?
Down.
Down.
Yeah, that. Yeah.
So,
That one. Last
part one.
Yeah.
Okay. Copy. Then go to the DMK. And deleting all the other things. Not useful. Escape. Paste. Part one. Here. File. Import. File. Import part in D drive. DMK. Part 1. Okay. So
Is it okay?
it's okay.
Yeah, perfect.
Actually, it is not perfect
I
because
know.
you can see from the bottom. It should be the shape of the tool. Okay, it will take time
Yeah,
to
just,
make.
yeah,
Oh,
just to show for.
so this
how
is
to
one.
work.
This is one part. So
Yeah.
what is the size? Diameter?
30 to 2. Oh, I forgot.
Okay.
Diameter is 30.
Diameter is 30.
Yeah.
Okay. Now you can make another part. Create another part, because in abaqus you have to make a lot of parts. You can see in this location part 1 is your tool. And one more thing, you can just change the name. It will help you. This is tool. Okay. Now you can create workpiece. WP 3D extrusion 30, then make it 100. 100 is approximate size of your workpiece.
Yeah.
So you will get a board of 100 by 100. So if the size is 30, you can make a circle of that size. 30 is diameter, right?
Yeah.
So 15. You can make from here to here. This will be your
Workpiece.
piece. Okay. So you can just trim trim, 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 cross it, done. The depth, suppose it is 20. Okay, so now this is your workpiece. Okay, so you will cut from this point to this one circular motion. Now next things, you have to define material. Okay, so create material. One is tool, so we will provide all the general density, whatever you have, everything, mechanical properties, elastic, everything. Okay, you can start it. Then the next material, okay, it is recording. So you have to create a lot of materials, create other materials like aluminium or titanium, whatever you are trying to machine. Mechanical elastic properties, whatever you want, you can put the values. Okay, I'm just putting. Now if you have defined material, you have to define section. Create section. One is tool section. Okay, solid homogeneous tool section. Continue, and you can put the tool material property in the tool section, and you can create another workpiece section, solid homogeneous. This is aluminium. Okay, now in tool, this is section assignment. Once you will click it, the tool will appear. So select the tool, and I'm not selecting it. Done. And oh, there's some problem. I think it is hollow. The tool is hollow, therefore it is not taking solid section. Okay, I'm showing how to assign section on workpiece. A similar way you can assign section to the tool if it is not hollow. I will show it. Okay, section assignment to the workpiece. Create, select it, done. Assign a section of workpiece. Okay, similarly you can assign section to the tool. Now this is assembly. Double click here, and you can put the instant from this point. This is workpiece. Select tool. Dependent and independent. Dependent means you have to mesh the workpiece or tool or any part in part module. Independent, you will mesh in the assembly module. So I am choosing dependent, mesh on part. Okay, so this is not matching. I think it has some problem.
Yeah.
Okay, no problem. So mesh, this is workpiece in part module, so you can mesh from this location. This is dependent, that is the mesh is dependent on the part. And if you want to independent mesh, you can go to the assembly. Assembly, and this is all stand tool, and there will be some mesh.
I think my tool timer is 60.
Maybe. Okay, so I'm meshing here. Workpiece, mesh, double click, part, workpiece. Okay, so go to mesh, control. You can take shape of the mesh element type. You can do explicit if it is moving, and coupled temperature displacement if you are trying to calculate temperature also. But if you will calculate through temperature, it will take a long time in simulation. Okay, just okay.
Can I ask you something? In tool, maybe the tool have this coating. So how can we input the property for the coating materials?
So coating will change two things: thermal conductivity,
right,
and wearness.
Wear.
So we will not calculate tool wear in this. So what we'll do, we will assign one reference point on the tool, and we will combine this reference point with all the elements of the tool via a rigid contact. Rigid contact means it will not transfer stress and it will not transfer
Right.
temperature. So
Right.
no need to define separate another layer.
No layer. Just
Because-
changing the
because
thermal
if-
conductivity.
It will have infinite thermal conductivity, or zero. Sorry, it will zero because no temperature can pass through the tool.
Yeah.
Because if you will allow tool to pass the temperature, it will again take a long time, 7 years of simulation. So that is
Right.
not possible. So currently, based on the current facilities, we define a rigid tool.
Only consider the
Only
rigid
consider,
tool.
like suppose you have this tool,
Yeah.
okay. So you will define a point somewhere here,
Right.
okay, and you will connect all the elements to the one point. Okay. So this is how you mesh on workpiece. Now assigning mesh size is a little tricky game. This is called seed. You can make seeds on the part. This is the simplest way. Seed, part, click, and the approximate global size means approximate size of all the elements is 3.4 units. If you click apply, it will assign. Suppose you want to make more fine mesh, so you can make it to 1.4 or only 1, so it will be more fine. Okay, but suppose if you want high dense mesh at this location, right, and here low dense, so make it 3 or 4, so it will be low dense. Click on OK, then go to the seed and edge, click here and select one edge. Done. And you can change mesh size here, 0.5. Apply. Okay, so it will make very fine mesh. Suppose your tool is starting cutting from this location and this is the important, but this is not important. So you want dense mesh here and low dense mesh here. So you can click on single. So this arrow shows by size, means size of the element in this location is suppose 0.5 and in this location it is 3, for example. So if you will click apply, this arrow is in this side, so you can flip this. It will come here. Okay, so here the size of first element is 0.5 and here the element size is 3. Suppose you want dense mesh here and here wider, or you want dense here and wider in other sides, so you can set double. If you will apply dense here, wider here, flip it and apply dense here, wider here. So whatever you want you can do based on by size. You can define by number also. By number means number of elements 16 and bias ratio is 5. This ratio set where you will the ratio between two elements. Apply, or you can flip it, apply. Okay, you can do none. So in the whole edge it will put 16 elements. Apply, or you can put 50 elements. Apply, whatever you want. 500. Okay, so you put less number of elements. Okay, similar thing you have to do here, but you want to do element number here and here same. So you can select both together. How? Do you know how to define set?
No.
Okay, so you can define set. Right click. Set is very useful. Suppose this is inside surface, so just type inside ins. Continue this and shift this and done. Edge. This is one side, inside edge, inside edge, and you want to mesh seed edge and click here set ins, continue and 35. So it will make 35 edge here and here. Okay, so this is all basic things. So I think I have to open one running simulation which I did. That may be more useful because that will have all the things. Okay.
So in this case, why its tool doesn't work?
I think tool is hollow.
Hollow?
Hollow. It has no inside surfaces. Okay. I am removing this surface. Okay. So this is again important thing. You can click here, you can click here, and you can remove this one. Hollow. Hollow tool. As I told you earlier, if you export, it may export only surface. In Pro Engineer you saw only surface, solid. I think you export only surface.
Yeah.
So this is a problem. And if you want to take this again back, click here, it will come. And if you will click it, so it will remain this and others will be deleted. Like this will be here. Okay, click here, it will come. So this is the problem. You have to take solid. Okay, so I'm crossing it.
Oh, can you explain about the summer analysis related with the summer analysis setting?
Yes. I think I will take one running model and I will explain everything.
Let's go. Oh.
Okay, so if you start abaqus, I'm starting from very starting. Go to the file, set work directory to here and select one working directory. Suppose this is July. Okay, and click on OK. Then open it. You will get one CAE. CAE file means full model.
Yeah.
Okay. Then it will open CAE. You can make multiple models like 2D experiment milling, 2D milling coupled, milling tool. A lot of models are there. So just I'm opening one milling coupled. So I made 3 parts here. Tool, this is copy tool, this is work. So you can see work. This is the work piece. Okay. So first I will explain work part. It has one feature, solid, extrude. I made one strip and extruded it. It has 2 sets. One is fix. Fix means outer surface. The outer surface is fixed during milling. Okay, we will cut the inner surface. Then work nodes. These are the nodes of workpiece. These nodes are useful to define interaction between the tool surface and the node surface. So we cannot select again and again the same nodes. So we define nodes 1 and we can just select nodes.
So why you only fix the surface?
Outer surface.
Nodes can do, yeah. Nodes can do the pieces, fixed condition.
Nodes are in fixed condition, correct. Suppose you have this workpiece, right?
Yeah.
Okay. And your tool will go from inside, cutting from inside. So it is required to fix the outer surface.
Outer surface
Only outer surface is fixed, and the interaction between the tool rake face and all the nodes of the workpiece is on. Okay, so we have 2 sets and section. This is the work solid section assigned to the workpiece. So if you want to see this section, go to the section and click edit, and you can see that TI means titanium is selected. Okay, so we have defined this titanium in millimeter. Titanium stress means it has no thermal properties. Tool with stress only. And one interesting thing is rigid body tool. So we have this solid tool. And this is reference point, this one. So this reference point is attached with this tool rigidity. So I'm showing you this is the coupling constraint.
showing tiny.
This is the
I understand.
so this is attached. Okay,
Yeah.
but this is one point only. Sorry, one float. You
Yeah.
want to see the 3D milling tool float, right?
Yeah.
So this is 3D milling tool. All the cases are here. Case 1, case 15. So we have two parts, tool and workpiece. Materials, titanium, tool. Section tool, workpiece, assembly, work 1 and tool 1. And one more thing, if you will define some set here, suppose this is set, reference point, you defined here, and if you go to the assembly and sets, you will get RP in tool 1. Whatever you will define here, it will reflect in assembly. So every set, every surface, it has 5 surfaces, and all the surfaces have been created on part mode.
Okay.
So in part mode, it is easy to select something. Do you know steps? I think you did one.
Yeah.
So you know steps. Okay, so I will explain only new things which are not in the
But
rolling.
this is for me and after student of me.
But you have to edit it because there's a lot of things which is not
No,
useful.
I'm not pro. You are the pro, and please explain them. Can you wait?
So I can stop it. As I have mailed you, I sent you one mail for downloading all the CAE files. So do one thing, download one CAE file, open one model and start from starting. From part it is 2, means it is useful. Calibration, it has nothing, means it was not used. So open part, look on it, on this part, how many features, everything. Look on the workpiece. Okay, then next is material, how material is defined, sections, steps. Okay, then field output. Field output is whatever we can see on the screen, it's field output. And history output means we can take in numerical format in notepad file or excel file. This is history output. So you can see here, set tool reference point. I have chosen a reference point for only 2 forces, RF1, RF2 and RF3.
This one FXYG.
Yes,
1 is X, 2 is Y, and
3
3
is-
is G.
only 3 because others are not important.
Yeah.
So if I will click all here, it will take long simulation time. Not useful. Okay, in field output you can take more than this: stress, strain, velocity, location. Status means element deletion.
Can you wait? Can you open that?
This one,
Yeah. And then stress.
stress, displacement, failure, temperature, state field.
Open.
This is
So
scale.
actually,
SDG means scalar stiffness dictation.
right.
This is important.
I mean, why you choosing that option?
This
Yeah.
because SDG is responsible for element deletion, for status.
Status.
If SDG will be 1, the status will be 0. It means element will delete. Okay.
So if I if I need to delete the machine, that is only
You need status.
status.
If I will off this status,
This one.
unclear,
Unclear.
then the element will delete, but you can still see. It will be visible. Distorted element. Status means what is the current status of the element.
Right. So first one is I click this one, and then if I click this one, and then it should be click this one.
Yes. But initially you click all, because
Right,
if
yeah.
suppose you unclick this, U and V, unclick this, for example, then the simulation will run.
Yeah.
The stresses will be changed, but you cannot see a moving tool. Tool will stay on their position, workpiece will stay in their position, but the stresses only change because velocity and location is not recorded.
So can I thinking like this one? If I check option that one, that is can the
This is
updated
stress.
visible, right?
Huh?
Like updated visible.
Yes.
That is updated for
First you
visible.
click all,
Right.
and slowly you delete 1, 1, 1, 2, 3, delete everything which is not useful. Okay. And then go to the interaction is very important. If you will not define interaction, the tool will pass the workpiece without damaging the tool, because the tool will don't know what is this workpiece. So you have to define interaction and reference between the tool surface and the workpiece node. Then this is the interaction properties. Constant origin means between the reference point and the tool. Okay. Then boundary conditions: fix to the end of the workpiece, rotation to the reference point, and sink to the outer surface. It's constant temperature. Predefined field is what is the initial temperature, 300 degree Kelvin of the workpiece. And then go to the create a job, create from model, case 115, continue, personalize, make it more than date, and MPI, click on OK. I'm not clicking OK, and just submit it. It will consume all your processor. This will go to 100%. Okay.
What's that? That one. This one. Okay. So first is you making this the milling tool from the website, and then cut from only this part,
Yes.
and then you make and then you import in the abaqus program,
Right.
and then you make the workpiece like this. So is it have only
It is only one,
one?
but I made different sections for mesh.
You
This
did
has fine mesh.
fine math.
This is just cut one piece.
And then this
One piece is cut in different sections.
different sections only.
Initially, you do not cut.
Right.
Only one single piece.
So this one, that
This may be for high-speed simulation.
speed simulation. So when if I open the link files, so then maybe this part is the fine meshes.
No. Initially, I do not use fine mesh. Once the simulation runs successfully, you can change it in fine mesh. Otherwise, you will take a long time.
And then, so how can you assembly this one?
How can I assemble? Just put here. Okay, again. If you will see assembly, you will see this.
Right.
Translate, you can move the part, rotate, you can move the part. So you can translate and rotate, you can set rotation and motion, you can set your part anywhere.
The thermal analysis.
This is thermal analysis.
This is not thermal analysis.
This is thermal analysis.
Thermal analysis.
Step, double click on step 1, double click. Dynamic temperature displacement explicit. This is thermal analysis.
Thermal analysis actually take a long time, right?
Yes.
Interaction. Yeah. How can you setting for the convection?
I have calculated this value 0.025.
Why?
This is based on air coefficient of heat leakage.
But this one is film
Film coefficient.
and then sink. So
300.
I don't know about this one and this one.
But film coefficient.
Film coefficient.
Do you know thermal leakage
Summer leakage.
on the surface?
No, I don't know.
Radiation, do you?
Yeah,
And what are the other two? Convection.
convection, conduction,
Yes. So this is convection coefficient on air 0.05.
convection.
Convection coefficient.
Coefficient.
Yes. And the sink temperature means 300 is the temperature of air.
K.
Okay.
Cabin temperature.
But make a copy and write all the units,
Right. Yeah. Compared to the same.
same units.
Right.
Because if you will miss, then it will be difficult. And mostly try to use Kelvin because it does not go in negative. And you cannot put negative values here. So try to use Kelvin.
Convection. This surface only work surface, whole surface.
Only outer surface from here to here. This is for convection.
Why didn't you this one?
Tool.
Yeah.
Tool is rigid body. No temperature, no stress.
No stress.
If the stress will go to the tool, temperature will go to the tool, you have to define thermal interaction between the tool and the workpiece. Is if the tool is, what is the distance between tool and workpiece, and
Right.
based on the distance, thermal conductivity will change. It is again very difficult. At what distance it will be infinite, at what distance it will be zero.
This one is the friction coefficient.
Yes.
And this is only rough.
Rough. This is rough.
Only
Actually,
rough.
I made this surface, the red surface here, for sticky zone.
Right.
So this is sticky zone. Yes, the workpiece cannot flow.
But in 그러니까 this one and then true surface can do the contact workpieces. Why you only give it to the rough friction only this one edge?
Rough on the edge, and this has some friction coefficient. This has some friction coefficient.
Right.
And the workpiece can flow on this rake face, but it will stick in the edges. Actually, the stick length should be 1/3 of the depth of cut, but that was creating problem. So I reduced the stick length.
You only use that rough friction.
The friction for a small portion.
So if I wanna more the precisely for the friction, so I just can give it to the boundary condition. Friction is this one and this one and this one. Give it to some what's that?
Penalty friction.
Yeah, penalty.
And your kinetic, whatever you want.
And then friction this one.
Yes.
Okay.
This is defined. You give me this actually. This is defined here. Tool workpiece.
Two workpiece.
So this is also the friction.
Right.
Where is the friction? This is friction. So this is friction. This is 0.2. This is friction stress only. 0.4. And this is frictionless. I define a lot of friction properties.
Friction.
Whatever is important, we can use. You can define lot of properties here,
Yeah.
and whatever you want, you can just use. You can select from this point any property.
Right. So what's that? What's the meaning of this one? Stress only. Stress only.
Stress only means I haven't defined thermal interaction between the tool and the workpiece.
Depend on the summer and the friction is changing.
You can define two things: roughness as well as thermal conductivity.
Right.
And if you will define both the things, the simulation time will be very long. Stress only means only roughness,
Only roughness.
no thermal conductivity. this become about 1 hour 5 minutes.
Can you show me the result?
Which is
Result section. Actually, I just after the analysis, I opened the modeling, result modeling, and then I don't know about how I see the force or stress. I don't know how to get the information from the modeling.
okay. I'm opening ODB file.
Right. Yeah.
Suppose this ODB file. So you want to see forces. Okay. So output this, and go to the history output. These are the forces. One direction, 2, 3, or you can plot 3. If you want to save, right click, save as is. Okay, and it will go here. Right click, edit, and you can copy it.
Okay.
Right click. You have to press Ctrl C for copy and use it
Can I distinguish the
in Excel.
No. I mean, why is that the flood is like this?
Due to
This one is
big mesh size.
contact this one.
Mesh size is
because
big
of mesh size.
because interaction between node and the work surface.
Right.
One node is attached, tool is going, force is going. Then next node there is some distance. Due to that distance, it is like this.
So actually, first contact and the middle of contact is the difference. The region is the maxima.
Tool is rotating
Right.
and the
Maximum chip thickness.
chip width thickness is increasing.
Increasing.
That's why. So you can see here
Wow.
to rotation.
Very difficult.
Very difficult, but if you will do so, just right click here, set rotation center, then you can rotate it easily.
Right.
Okay. So you want to see, if you want to see a good image, so you have to remove this mesh lines. Go to the option common and feature is only. It will it's more better. So you can see mesh size is very big.
Okay. This is because of the max
Yes.
node size.
All edge. Mesh
Right.
size is very big. Okay.
Then this one is okay, and then how can we define the true stress?
True stress.
True is rigidity, so we cannot
You cannot define stress on tool.
the interaction stress.
Stress on workpiece only. Here you can define.
So the shear stress.
So do one thing. First you repeat all the things, otherwise you will
Okay.
So I think I will record one more lecture.
Yeah.